बिस्मिल्लाहिर्रहमानिर्रहीम। सेकेंड ईयर के स्टूडेंट्स जो मैथमेटिक्स के लेक्चर मैंने पहले दो अपलोड किए हैं, दो तीन, ये उसी की कंटिन्यूटी है। चैप्टर नंबर 1 लिमिट्स एंड फंक्शंस का जो चैप्टर है वो हमने आगाज़ किया हुआ था। अब ये रेगुलर 9-10 के पेपर चले गए हैं, तो मैंने अब मेरा जो तवज्जो होगी वो फर्स्ट ईयर सेकेंड ईयर के मैथमेटिक्स की तरफ होगी ज़्यादातर, ताकि जितने चैप्टर हो सकते हैं एग्ज़ाम से पहले वो मैं एक बार कवर करवा दूँ और पैटर्न के साथ ही कवर करवाऊँ। और इसके अलावा अगर कोई क्वेश्चन है आपका तो आप कमेंट सेक्शन में लिख सकते हैं, पूछ सकते हैं, मैं वो क्वेश्चन स्पेशली करवा दूंगा। खैर, वीडियो को आगाज़ करने से पहले इसको लाइक करें, सब्सक्राइब करें और शेयर करें चैनल को उन स्टूडेंट्स तक जिनकी बिल्कुल भी तैयारी नहीं है। मैं 2 से 3 चैप्टर कोशिश करूँगा कवर करने की, जिसमें डिफ्रेंसिएशन है, लिमिट्स एंड फंक्शंस है। ये 2 चैप्टर तो मेरी पूरी कोशिश होगी कि मैं कवर करवा दूँ सेकेंड ईयर के एग्ज़ाम तक। बाकी क्योंकि आपको पता है बहुत लेंथी सिलेबस है, जितना हो सका इंशाल्लाह कोशिश करूँगा करवाने की। तो आगाज़ करते हैं। हमने पिछले जो था अलजेब्रिक फंक्शंस की टाइप्स चल रही थी। अलजेब्रिक फंक्शन में आखिरी टाइप जो थी वो था रैशनल फंक्शन। एंड व्हाट इज़ अ रैशनल फंक्शन वी विल स्टडी टुडे। आपको याद होगा कि रैशनल नंबर्स क्या होते हैं। एक रट्टे वाली उसकी डेफिनेशन है कि द नंबर विच कैन बी रिटन इन द फॉर्म ऑफ पी ओवर क्यू, यानी कि ऐसे नंबर जिनको पी ओवर क्यू की फॉर्म में लिखा जा सकता है, वेयर पी एंड क्यू बोथ आर इंटीजर एंड क्यू मस्ट नॉट बी इक्वल टू 0। ऐसे नंबर रैशनल नंबर कहलाते हैं। इसके ऊपर बड़ी डिटेल डिस्कशन है, हो भी सकती है, लेकिन हम इसकी डिटेल में नहीं जाएंगे। नंबर सिस्टम हम यहाँ पे नहीं पढ़ रहे। फर्स्ट ईयर में इंशाल्लाह मैथ का जब चैप्टर 1 आएगा तो तब वहाँ मैं बताऊँगा इसको, उन लेक्चर्स में आएगा ये। फर्स्ट ईयर की क्योंकि ट्रिग्नोमेट्री चल रही है, लिहाजा इसको हम रैशनल नंबर्स को हम डिस्कस नहीं कर रहे हैं, यहाँ पे हम रैशनल फंक्शन को डिस्कस करेंगे। अब व्हाट आर द रैशनल फंक्शंस? रैशनल फंक्शंस, the functions which can be written in the form of p of x and q of x. Such function which can be written in the form of p of x over q of x, where q of x must not be equal to 0 and p of x and q of x both are polynomials, is called rational function. For example, you already well familiar what are the basic condition to for an algebraic expression be a polynomial. It must not contain any negative power, it must not contain any fractional power, it must only be consisting of the variable by which this polynomial is defined will be raised to power some positive in increment or decrement order. So when you define a rational function are simply defined as the functions which can be written as the ratio of p of x to the q of x, where q of x must not be equal to 0. And the second condition to be imposed on the rational function is that p of x and q of x both are polynomials. And you are well familiar what are the basic condition for an algebraic expression to be a polynomial. It must be its powers or the variable must be a whole number. For example, I can give you an example of rational function 2x squared plus 3x plus 5, 2x plus 5, and this is also polynomial, this is also polynomial, so this will be a rational function. But if you say, if we have another example 2x minus 1 plus 5, 3x squared plus 9, so if you say this is a rational function, this will not be a rational function because this is not a polynomial, because its variable raised to negative power. So above expression numerator is not a polynomial, while the basic condition that has been imposed on to be a function, a rational function, that p of x and q of x both must be a polynomials. So that's why particularly with respect to the entry test point of view, you need to remember these certain conditions. Otherwise, if you say, if someone asks you in exam, this is a rational function, and if you say this is strict, this will be wrong. Yes, this is a rational function, this is not a rational function. So this was all about rational function. Now we come towards the trigonometric functions. What are the trigonometric functions? That's very simple. There are total 6 trigonometric functions. one sine of x, second one cos of x, third one tangent of x, fourth one cosecant x, cotangent x, secant x, cosecant x. There are 6 trigonometric functions. And you know well, this is actually x is the domain and y is the range of the function. In case of trigonometric functions, all domain and ranges are given in your textbook. For examination point of view, you need to remember all domain and range of trigonometric functions. For example, it may be from 0 to infinity, from infinity 0, from minus pi by 2 to pi by 2. This will may range between minus 1 to plus 1. We will not go into the detail of all that. All you need to remember, these are 6 trigonometric functions with their respective domain and regions given in the textbook. You need to remember. Okay, now what are the inverse trigonometric functions? Like 6 trigonometric functions, there are 6 inverse trigonometric functions. And what are the basic concept of the inverse function? The functions which actually cancels the effect of original function. For example, if I say y is equal to sine x, if I want to determine x, so very simple, I will apply inverse of sine on both sides. Sine and sine inverse will be cancelling each other and you are left with inverse of sine. So just like there are 6 trigonometric functions and there are 6 inverse trigonometric functions, sine inverse, cos inverse, tangent inverse, secant inverse, cosecant inverse, cotangent inverse. These are 6 trigonometric functions. And also these 6 trigonometric functions have their respective domain and ranges both. The domain and range of all trigonometric and inverse trigonometric functions will be discussed in first year chapter 13 in much detail. So we are not going to discuss trigonometric functions and their domain and ranges over here. Yes, the most important thing, we will discuss the exponential function. This will be the new one and very much important with respect to the examination point of view and objective type. Exponential function. The functions in which exponent appears in which variable appears as an exponent is called exponential function. यानी कि ऐसा function, such function in which variable itself appears as an exponent. For example, if you say y is equal to a power x, this is actually base, this is exponent, and this is output. So you can see, for example, 2 power x, this is actually the number, and number raised to some power, which is actually the variable. So such functions in which variable appears as an exponent is termed as exponential function. In mathematics, in second year mathematics, because you are going to study calculus in chapter number 2 and limits and functions are the base of the calculus, you will deal frequently with such kind of functions. So that's why the introduction is of great importance at this level. All you need to remember, the function in which variable itself appears as an exponent is called exponential function, and there are many types. A simple exponential function, a natural exponential function. With the passage of time, as we squeeze to the next exercises, you will came to know that what is the basic difference between all those exponential functions. Now, and the deduction from the exponential function which we withdraw is actually the logarithmic function. The general function you can have over here, and we will define how what is actually the logarithmic function. If x is equal to ay, this is exponential form, and you know exponential form can be converted into the logarithmic form from 9th class mathematics. All of you are well familiar. This exponential term can be converted into a logarithmic term as y is equal to log a of x, with certain conditions you need to impose, where a is called base of the logarithm. A is always a positive number and a is not equal to 1. I mean, a is always positive number and a is not equal to 1. These are the conditions to be imposed on the when you are going to define the logarithmic function from exponential to the logarithm. Okay, now there are the two kinds. From objective point of view, very much important that I am going to tell you with respect to entry test as well. These two conditions you need to remember what are the necessary and the sufficient condition for a logarithmic function are. A must be, the base of the logarithm must be a positive one, and it must not be a negative, it must not be equal to 1. So if a equal to 10, if the base of the logarithm is equal to 10, why it can't be taken as 9, 8, 7, 1, 2, 3? Why is not equal? Why is always equal to 10? We will not going into the detail. If I have certain time in the few lecture in the coming days, then I will tell you why you always take equal to 1. Why a is not equal to 1? Why we take a equal to 0? Why we need to impose certain condition? All these questions will be answered in some extra lecture which are not related to the syllabus. If a equal to 10, then such log is called common log. And if a equal to e, and what is e? If you look at your calculator, you will find a key e raised to power x, which is called exponential. Remember, if a equal to e, which is actually the exponential function, if a equal to e, then it is called natural log. If a equal to e, then it is called natural log. And remember, log of e is represented by ln, which is actually the representation of the natural log, and you will find frequently in integration and as well as in differentiation. So this was all about the types of the function. One more lecture will be on the types of the function, and after that we will squeeze on exercise 1.1, which is actually the why we have discussed all these functions prior to start the exercise, just to make you sure you have a sound idea of all types of functions. And all these definitions are being asked in mathematics exam. I will upload all these definitions in a link given the end of this lecture. You can make them up and download, and all you are requested to like the channel, subscribe, and share with all the students who have nothing prepared, any single stuff in mathematics. Thank you very much. Allah Hafiz.